Hi class, in this recording we're going to focus on the male anatomy. We're going to talk about the spermatic ducts, the accessory glands, and the penis as a whole. As we look at the spermatic ducts, we're going to start with the efferent tubules. And when we see this phrase efferent, think of E for exit. These are the ductules, these efferent ductules that carry sperm away from the testes and carry the sperm ultimately to the epididymis. While the sperm is being transmitted to the epididymis, it's going to go through the head, body, and tail of the epididymis, so that epididymis is broken up into 3 regions. And the epididymis is the site of sperm maturation and storage. And the sperm can remain in the epididymis, remain fertile for 40 to 60 days within the epididymis. And this 40 to 60 days corresponds to the 40 to 60 days that most men need to wait after they have a vasectomy or their vas deferens snipped. And as we look at the epididymis, it has a single thick coiled duct. And I'm going to advance the slide here just to give you a different view. So the epididymis is located right here along the surface of the testes. And that epididymis, within the epididymis I should say, we have that single coiled duct that if we were to unfurl it would be approximately 6 meters or 18 feet long. The mature sperm are going to have to travel all the way through the duct, and if the male does not ejaculate, those mature sperm eventually disintegrate and are going to be reabsorbed within the epididymis. The individual does not develop blue ball, which is something that a lot of my male students were convinced about. About a decade ago, that was a popular misconception, but I just want to lay it to rest. Your testicles do not swell up and become overly painful in response to the sperm building up. If the sperm are not ejaculated, they disintegrate and are reabsorbed into the epididymis. As we look at the spermatic ducts, we're going to continue from the epididymis to the next stage, the vas deferens or ductus deferens. And this is a tube that's muscular. It has a lot of smooth muscle with peristaltic movements that are going to milk and push the sperm up through the scrotum, through the inguinal sac, and then that's going to pass all the way inferiorly to the urinary bladder to enter into the prostate gland. And as this duct is getting closer to the prostate gland, it's going to widen and form the terminal ampulla of the ductus deferens. And we find that this ductus deferens is going to be innervated by sympathetic nerve fibers. So we're going to come back to that later. We have a sympathetic innervation of the smooth muscle of the vas deferens. And then that vas deferens will drain into the prostate gland through a tube known as the ejaculatory duct to get the sperm into the prostate gland. The ejaculatory duct is distinct and unique from the prostatic urethra. And it's worth emphasizing that there are 2 ejaculatory ducts. It's formed from where the ductus deferens and the seminal vesicles merge and pass into the prostate gland. Speaking of ductus deferens, or seminal vesicles, let's talk about some of the accessory organs. We have accessory organs in the terms of accessory glands for the male reproductive system. They are the seminal vesicles, the prostate gland, and the bulbourethral gland. And notice we have some plurals and a singular. We have 2 seminal vesicles, 2 bulbourethral glands, but only 1 prostate gland. And as we look at the seminal vesicles, those seminal vesicles are located on the posterior of the urinary bladder, and the seminal vesicles and the ampulla of the vas deferens merge together to form the ejaculatory duct, and it will drain into the prostatic urethra. The seminal vesicle secretions form approximately 60% of the total volume of semen. As a frame of reference, the testes themselves that make the sperm produce only 5% of the overall volume of semen. So when individuals are looking at getting a vasectomy and they're concerned about the amount of output during intercourse, a vasectomy has a very negligible effect on the overall sperm volume, on the overall semen volume during sexual intercourse. The 2 seminal vesicles are the first accessory glands of the male reproductive tract. The prostate gland is the second accessory gland of the male reproductive tract. And this prostate gland is going to surround both the urethra, the prostatic urethra, and the ejaculatory ducts, and will be just inferior to the urinary bladder. The prostate gland is going to have approximately 20 pores that drain into the prostatic urethra that will secrete a thin, milky liquid that forms approximately 30% of the volume of the semen. So the two seminal vesicles and the one prostate gland produce approximately 90% of all semen volume. 5% comes from the two testes, and then the remaining 5% comes from the two teeny tiny bulbourethral glands, sometimes referred to as Cowper glands. So these bulbourethral glands are also known as Cowper's glands. That's an old school name that's been in the process of being phased out. And the bulbourethral glands are just next to the bulb of the penis, where the erectile tissue bulges outward. When a male is sexually aroused, the bulbourethral glands are going to produce an alkaline fluid that's very slippery, and the purpose of this alkaline fluid is to neutralize the acidic environment of the penile urethra and to lubricate the glans penis, or head of the penis. And that alkaline lubrication of the glans penis makes it easier for the glans penis to penetrate in between the labia minor and access the vagina. Also, the alkaline secretions from the bulbourethral gland are also going to neutralize the acidic environment of the vaginal canal as well. As we look at the penis is primarily used to deposit semen into the vagina. It's a delivery mechanism. And as we look at the penis, half of it's going to be an internal root, the other half is going to be visible as a shaft and head. The amount that is visible is going to depend on how obese someone is. As somebody has an increase in obesity and has more and more adipose tissue added to the hypodermis, the shaft of the penis doesn't become shorter, but the shaft of the penis is going to become encapsulated or surrounded by adipose tissue. So it may look like the shaft of the penis becomes shorter as someone is putting on body fat. As we look at the external portion, the shaft and head of the penis, it's approximately 4 inches long when it's flaccid and 5 to 7 inches long when it is erect. And depending on the individual, we can have some variation here. Sometimes it can be as short as 3 inches when flaccid and increase it could go from 3 to 7 inches. So there's just like there's a spectrum of size and activity within the female reproductive system. Just think of women and how they have A cups versus B cups versus C cups, different sizes of breasts. There are also a wide variety of sizes of penises, or peni as well. As we look at this penis is uncircumcised, and you can tell it is uncircumcised because there's a fold of skin known as the pubis, or foreskin, that is over the glans penis. And the process of slicing off that pubis is known as circumcision. And this pubis is very relative to the glans penis. The pubis itself has very few sensory receptors. As we look at the penis has 3 cavities of erectile tissue within it. These cavities of erectile tissue fill with blood when a male is sexually aroused. And it accounts for the male having an erection. This is what gives the erection. So we have a hydraulic system. So we have a fluid-filled tube network to cause the penis to become erect. The 2 primary kinds of erectile tissue are the corpus spongiosum and the corpora cavernosa. As we look at the corpora cavernosa, that corpora cavernosa is going to form two cavities that ultimately will branch to form a Y-shaped structure. Whereas the corpora spongiosum is going to enclose the penile urethra, or spongy urethra. The spongy urethra is in the spongy erectile tissue, or in the shaft of the penis. And you can see that corpus spongiosum inferiorly right here, or ventrally right there. And as we look at the corpus spongiosum, it is going to dilate to form the bulb of the penis. And as we look at this corpus spongiosum, it's surrounded by a muscle known as the bulbospongiosus muscle. This is a muscle that is responsible for some of the ejaculatory pumping associated with ejecting semen from the male's reproductive tract. That's all we have for this recording. If you have any questions or comments, please feel free to post them on the class discussion board or to shoot me an email. And as always, happy studies.